Our next speaker is an iOS developer at Detroit Labs in Detroit, Michigan. Yes, it really is in Detroit. Everyone asked that. He's the author of Learn Cocoa Touch for iOS. He's also the author of the world's best iPhone game, Finger Treadmill. Jeff Kelley.
So we're going to go from one really straightforward concept with no race conditions or gotchas, networking, right to another, dates and times. Very straightforward. We've all seen problems with dates and times in apps. Every single year, it seems, daylight savings time happens, and all these articles come out about people's iPhone alarms that didn't go off. And it's like every single time they can't get it. Dates and times are really tough. But why? So to help explain why date and time APIs are so hard, I've called in a friend who's an expert on date and time.
People assume that time is a strict progression of cause to effect, but actually, from a non-linear, non-subjective viewpoint, it's more like a big ball of wibbly-wobbly, timey-wimey stuff.
Exactly. So the thing is, we all know how date and time works. Like, ever since we were in grade school, you learn to read a clock, you learn to read a calendar, you hear about what daylight savings time is, and you think you understand what it is. So you take that knowledge with you and you begin programming this kind of stuff, and things don't act like how you expect them to. There we go. So you start using the NSDate class, and you say, dates, I know what a date is, and it turns out it's not quite what you think. Then you finally get Cocoa working, and you're like, cool. And then you talk to web services that are using other date libraries that give you these weird formats. People give you weird time zone issues. And then time zones exist, so that's always fun. And then daylight savings time is another wrinkle that makes all this stuff tough. So let's look at NSDate. So here's the header. It's pretty sparse. There's really just one thing, which is this time interval. And so being the advanced programmer you are, you say, all right, what are they hiding from me? Whoop, uh-oh. The end presentation button is right under the next button. So you go through with the Objective-C runtime, and you're like, all right, I'm going to get all of the instance variables of NSDate. I'm going to see how it's built. And so it's pretty trivial code to just iterate through them. And you go to it, and you get nothing. Nothing comes out. And you're like, what the heck? How does all this stuff happen if NSDate doesn't have anything in it? Turns out NSDate is basically a double. It represents a moment in time. On this platform, it's measured from the first day of 2001. And so all the calendar stuff, all the time zone stuff doesn't apply to NSDate. It's just, here's this moment in time. And you can subclass it if you want. If you want to make an NS star date, because you're going to do stuff with Star Trek, you can make the reference date a different time. So if all this stuff isn't in NSDate, where is it? First step is NS calendar. And that takes care of all the stuff that's more than that. So splitting a date into the month and the day and the year. So the things that are actually on a calendar on the wall. It takes NS dates and creates them from those individual pieces. Now, I love the documentation on date and time APIs. They have, whoever wrote them is great, big props, because they use really cool words like reckoning time and calendrical computations. But basically, think of the calendar as the way to translate from a moment in time to how a user thinks about time. Now, most of the time we use the Gregorian calendar. There are other calendars like Japanese and Buddhist. I think Tim Cook mentioned something about the Chinese calendar being improved in iOS. So one more calendar. And the big things they do is they split dates into components. They take components and make dates. And they also can do operations on them. And calendars are weird. So there's a command line thing you can do called cal. You type it out, and you just get the month. I wrote this in February. But way back in 1752, we switched from the Julian calendar to the Gregorian calendar. And but somebody forgot some of those days. So if you go to that month, that's, what is that, September? You see that there's some days missing out of it. And you could print out the whole year, and September just looks funny. So yeah, calendars are weird. So how you use it is date components. So first off, we make ourselves a calendar. Then we make a date components object. And we're going to set different things that we know about the date. So the year, the month, the day, the hour and the minute, and even the time zone. There is a standard list of abbreviations for these time zones. And then we can make an NS date from all those components and figure out what that moment in time was. So I have with me fabulous prizes in that area. And the first prize goes to whoever can tell me what happened at this date. Yeah, who's that? You are the first winner. This is when Steve Jobs introduced the original iPhone. Now, I know what you're all thinking. That is a lot of square brackets. Well, if you happen to be using a different language, like let's say Swift, this is how you would do it. So in Swift here, it's pretty much the same. We get a calendar with the Gregorian identifier. We make a new NSDate components object. And just like in Objective-C, we set the components on it. So for another fabulous prize, what's this one? Yes. Sorry, I'm not going to give you two. I'll give one to him. Yeah, that's when we landed on the moon. We'll do two more, just to get you used to making date components. So now we've got two of them. There's date components and next components. And this time, all we really know about them is the year, the month, and the day. You don't need to have all the information. You just put the components you know into the date. That's correct. So that's the last time it came and the next time it's coming. All right, now we're going to bounce back to Swift one more time. This is a very small example. In this time, all we know is the day that this happened on. No. Correct. That's the day Star Wars came out. You guys are good. All right, winners, see me after the talk. I'll be out in the hallway. Fabulous prizes. Now we can go the other way. So when you have a date, in this case we're going to use the introduction date of the iPhone, that first one. You can ask the calendar for the components that you care about from that date. So in this case, we want to know what the weekday was. And we get back 3, which is Tuesday, starts 1 is Sunday. There's a big list of all the things you can get from the era, which is like AD and BCE, all the way down to the nanosecond. And there's a slight modification from the header because there's a bunch of deprecated stuff below that you don't care about. It's similar in Swift. This is what you get if you command click on one of those constants. Just basically the same thing, but this is how all these constants appear in Swift. I thought that was kind of cool. So, dates versus date components. If you have two NSDate objects, right, they're just doubles. So it's really easy to say which one happened before or after the other one. You just compare the numbers. So that's what you use those for. And date components, they know where they are on a calendar, but not in time. So if all you know that it was 9 a.m. on a certain day, and then another date component is 10 a.m. on a certain day, but you can't reason about whether one of those was before or after because you don't know the time zone. And so there's not like mathematical certainty. Whereas with an NSDate, just this is a moment in time. I know when that is. So to see which one of two dates occurred first, you just use the compare method, just like anything else. And you can also do date components between two dates. So we've got this is to add 7 days. So what we're doing here is we make this date components object called diff, and we give it a day value of 7. And then we add that value to the current date to get a new date back. Now, you might be saying to yourself, I know how to add that. I just get the date object, I figure out how many seconds are in a day, and then I add that to it. It's just a double. I just add seconds to it. Don't do that. Because what happens is, a couple months after you ship this, daylight savings time happens. And now you're off by an hour every time you did that. So, okay, no problem. No problem. We can reason about daylight savings time. I'll just write that code. So I'm going to find out when's the next time daylight savings time happens. And then if that's before the second date that I got, well, let's check. Should I go forward an hour or backwards an hour? And then once I know that, I just add or subtract an hour as I need. So it's easy. It's really fine. Yeah. When you use the NSDate components and NSCalendar APIs to add that week, it will take into account the fact that you're just trying to add a week. So always use those when that gives you enough. So when you know you're just adding this unit of time, go up to the NSCalendar APIs and use those. Now, here's another example. I'm going to make a date, which is now. So if you call NSDate date, you just get the current date. And then I'm going to make a date components for when Rome was founded. So in this case, the era is 0 because it was BC. And the year is 753. It's April 21st, right? So then I get an NSDate that represents when Rome was founded. And then I go and I get the difference. So I tell the calendar, give me the number of days, that's the components, from when Rome was founded to now. And what I get back is like, what is that? Some million days? I don't know. It's been a long time, right, since the Roman Empire was founded. So that gives me days. If I wanted years, where I say NSDay calendar unit there, I will now use a bit mask. It's NSyear calendar unit as time. They represent, some more awesome language from the docs, geopolitical regions. So there's America, and there's this weird one in Indiana, Petersburg, because Indiana is very weird about daylight savings time. And these represents offsets from GMT. And you can make a time zone just with an offset. Say we're 240 minutes behind. But if you use the abbreviations, then you get daylight savings time. Because otherwise you have to know, is it currently daylight savings time? If not, it's 4 hours. If it is, it's 5 hours. It's a mess. So what you want to do is make your time zone like that. And then you can ask it, is it currently daylight savings time if you need to? And that can change. Somebody could be playing your game at 2 in the morning on the day that daylight savings time happens, and now all of a sudden it's a different time zone than when the app was opened. So that's fun. And there's a notification you can sign up for. It's NS System Time Zone Did Change notification. Make sure you test that. Now I mentioned Indiana. This is a map I got off Wikipedia. Every different color on this map is a county in Indiana, and the different colors do times differently. I don't know how we got here, but this is how it is. So that blue dot, let's say that's your user's location, right? And you get back the list of stores from your API. And they're just various places around the user. Let's say what you're trying to show them is which ones of these stores are open right now. Well, there could be several different time zones at work, and if all you have from your API is that the store opens at 10 a.m. and closes at 6 p.m., well, that might not be enough information to answer that question. You're going to have to know what time zone they're in so you know what time it is there and not just what time it is for the current user. And if you're thinking that this is some kind of edge case that you shouldn't worry about, if the user uses your app to see if the store is open and they need something there, and they go there and it's closed, you've now given them bad information. And you've lost their trust. And every single thing your app tells them is now going to be looked at as potentially false. So don't do that. Now, if you need to print a date for the user, NSDate formatter is your friend. It takes a date, turns it into a string. It can also go the other way around. Since a date also includes time, another confusing thing about the API is that NSDate also handles time. That's how you print time of day. And the cool thing about using this is that it'll take advantage of the user's locale to print it properly. The same code will print things for different languages and for different regions. And they're really easy to make. So we've got our date, and we're going to give it a 0 interval since the time interval. So this is January 1st, 2001. We make a new date formatter, and we set the style. So for the date, we want the full style. For the time, we want the full style. Give it GMT time zone. and then we print it out. And if you change the locale of the simulator when you run this, you get different results. For instance, in France, they don't capitalize Monday or the January. And I didn't have to write that, right? I didn't have to know French to get that to work. And you can change that constant we gave for the style. So here's long style, a little bit shorter. There's medium style, and short style. And if you only want the date or you only want the time, you can only have those and use no style for the other one. So don't do this. Don't have your month, day, and year in an integer and then just throw it through a quick format string. Because that's going to be fine. It's going to work. And then you're going to ship your app in the UK. And now everyone's going to complain. So you say, OK, I got this. No problem. You just figure out if the current user's locale is in the UK. And if it is, you do the other format string. And if it's not, you do the one we wrote at the first. So it's fine. No problem. And if you're thinking to yourself, that's fine, but my app is never going to be localized, guys. Yeah, but all your strings are hard-coded, too. You ever have to go through an app, find every string, and localize it? It's not fun. So NS date formatters, they're very expensive to create. And certain operations on calendars can be pretty expensive to run. So you're going to want to create these once, keep them around, and then you can give them a format, and it'll localize everything for you. You can also do custom formats, so not just those constants. Here, I make a date formatter for the RFC 3339 format. Just year dash month dash day, T, hours, minutes, seconds, and the Z stands for GMT. So now I take a date, I run it through the date formatter, and I get that output. And that's suitable for sending up to your web service that uses a different format. And that's also how you would format going the other way from that web service. So some shortcomings. This is limited to the planet Earth. So anytime you're going to go to the moon, you're going to have to take into account relativity. These APIs don't really handle that for you. And now time zones. So I was on the plane on the way here. I was coming from Detroit. So my first stop was in Dallas because I got terrible tickets. And I set my Fitbit. I told it to change the time zone. It gave me this warning. It said, hey, if you change the time zone and you go backwards, you could lose data. And I'm not blaming Fitbit. Like, I'm sure there's a lot of engineering that had to solve that problem. But what that means is they're probably storing that data in local time. And you always want to store everything relative to GMT. Just use the NS date if you can, because it's a double. It means it's very efficient to store. But if you have to store it, either use GMT or specify the time zone when you store it, or just say in your app, this is the time zone we're storing everything in. Because if you have two things that you stored as like 9 a.m. and you don't know what time zone they are, then you can't effectively reason about which one came first. And you're going to have problems with sorting, and it's going to look like iMessage. Now, if you want to do something like mail.app where it says 2 hours ago, 30 seconds ago, that's not built in, although I may have seen something in the API diffs, haven't looked really closely. But Matt Thompson, of course there's an open source Matt Thompson library because he wrote everything. There's a thing called Formatter Kit. And that gets this for you. I don't have enough time to show you on GitHub, but it's just a huge file that does this. Use that. It's a lot better. Now, my last example. You're thinking this stuff is all easy. Let's say you wanted to know when Easter is. Now, as we all know, Easter falls on this first Sunday after the first full moon following the March equinox. It's the Paschal full moon. And there's this easy to understand equation to compute the day from the year. It's called Computus. It was invented a long time ago when we gave algorithms really cool names. So I wrote this in Objective-C. So this is a method that gives me back date components for Easter given a current year. Yes?
There's also Greek Orthodox Easter, which is different.
Yes, there are multiple Easters. This is the Easter that is celebrated by Christians in America. So There are multiple Easters. This is one of them. So very easy to follow. You just go through all these steps, and finally, you can get the month and the day to put in the components. So you run this. You say, give me Easter this year. You give it 2014, and it tells you Easter this year is on day 20 of month 4. And it was. Now, if you wanted to write this in Swift, it's pretty similar. Just going to use lots of lets because those values aren't going to change. We've got our components. We put the year in, then we compute the month, compute the day, and return it. And if you call it, we'll do 2015 this time, you get April 5th. So pretty straightforward. So if you want further reading, Apple has a date and time programming guide that goes through a lot of this stuff and has really good examples. And then there are 3 articles on NSHipster I would recommend. So NS Date Components and Formatter. And then lastly is NS Data Detector, which is how you can do cool things like detect a date in a string and extract it out when it's just with a bunch of other text. So that's date and times Cocoa. Any questions? Yes. There's a microphone coming. There's a microphone coming up to you. 1 second.
Do you know, have you seen any way to find out how many days a week in a given calendar has? Or is that an omission? Like most calendars we know, I believe, have 7 days, but I don't know. Like that's something that I was asking myself, what if the user is on a lunar calendar or on one of those other non-Gregorian calendars? Can I also assume that their week has 7 days, or might it have 6 days or 5?
So this is the list that I found of all of the constants for what components you can get from a date.
It's not in the constant.
It's not in there. So, what's that?
No.
So
no, it's
weekday ordinal won't give you what you want. So there is no call to get the number of days from a week, as far as I know.
There is a call. I forgot what it is, but there is a call that you can ask for the number of components in a certain era. So you can ask like, what is the number of weekdays in a certain era in a certain calendar? I believe there's sample code in one of these guys that he linked.
Yeah. So if you all thought that you knew everything about dates, guess what? Not every week has 7 days. That's one more thing that could trip you up.
All of the dates supported by iOS and OS 10 have 7 days.
Okay. So all of them supported by iOS and OS 10 so far have 7 days, but you never know. Mm-hmm.
I have a question, or I have something to add. I'm Dutch. My time is set to 24-hour clock. If you don't use NS Date Formatter, I hate you because your app will not show up in 24-hour clock. Mm-hmm. Same goes for the date formats. So please use NS Date Formatter. Even I live in America, but I still use my trusty old date format. So please do it.
Yeah, Using NS Date Formatter, it takes that choice away from you and it gives it back to your user. What format they want it to show up in, what language they want it to show up in. So it's very important. All right, well, people who won the fabulous prizes, I will be out in the hallway directly after this. Come see me. Thank you.
Here is an iOS developer at Detroit Labs in Detroit, Michigan. Yes, it really is in Detroit. Everyone asked that. He's the author of Learn Cocoa Touch for iOS. He's also the author of the world's best iPhone game, Finger Treadmill. Jeff Kelley.
So we're going to go from one really straightforward concept with no race conditions or gotchas, networking, right to another, dates and times. Very straightforward. We've all seen problems with dates and times in apps. Every single year, it seems, daylight savings time happens, and all these articles come out about people's iPhone alarms that didn't go off. And it's like every single time they can't get it. Dates and times are really tough. But why? So to help explain why date and time APIs are so hard, I've called in a friend who's an expert on date and time.
People assume that time is a strict progression of cause to effect, but actually, from a non-linear, non-subjective viewpoint, it's more like a big ball of wibbly-wobbly, timey-wimey stuff.
Exactly. So the thing is, we all know how date and time work.
Our next speaker.
Like ever since we were in grade school, you learn to read a clock, you learn to read a calendar, you hear about what daylight savings time is, and you think you understand what it is. So you take that knowledge with you and you begin programming this kind of stuff, and things don't act like how you expect them to. There we go. So you start using the NS date class, and you say, dates, I know what a date is, and it turns out it's not quite what you think. Then you finally get Cocoa working, and you're like, cool. And then you talk to web services that are using other date libraries that give you these weird formats. People give you weird time zone issues. And then time zones exist, so that's always fun. And then daylight savings time is another wrinkle that makes all this stuff tough. So let's look at NS date. So here's the header. It's pretty sparse. There's really just one thing, which is this time interval. And so being the advanced programmer you are, you say, all right, what are they hiding from me? Whoop, uh-oh. The end presentation button is right under the next button. So you go through with the Objective-C runtime, and you're like, all right, I'm going to get all of the instance variables of NSDate. I'm going to see how it's built. And so it's pretty trivial code to just iterate through them. And you go to it,